Okay, so hello everyone. Ngayon tutuloy natin yung problems in fluid mechanics. Last time we did 1 to 5 in sa module 1. Now we'll do the rest of the problems 6 to 13. So yun nga, I have a class later, so let's do this quickly. So for the sixth problem, if the wreckage of the ship that sank in the ocean is 2,800 meters under the ocean water, also the density of cold salt water above it is 999 kilograms per cubic meter. Then calculate the pressure at that depth. So again, this is just the rho GH formula. So palagay natin na merong water dito and then the wreckage is somewhere around here. And that's really the best ship. But so dito yung height, 1,800 meters. Ito yung height. And then the density of the salt water is 999. Okay. And then we're asked to find the pressure. So lagyan natin pressure at the wreckage, P wreckage. So for the solution, P wreckage is rho GH equal to rho GH. And substitute the values. .81 second squared 2,800 meters. Okay. So, yan nga, if you're wondering, review natin konti. If paano ito nagiging pascals. So, let's do some unit analysis right here. Times meters per second squared times meter. So, di ba makancel tong dalawang to, and this will be left with 1. So, we have the unit of kilogram per meter second squared. But we're not really familiar sa unit na to since yung ginagamit natin is Newton per square meter. Ang katumbas nito is kilogram per the inverse. So, we're not really familiar with that. So, ang pwede natin gawin is we can just multiply this whole equation by 1. And what I mean is yung meter over meter. Since we're multiplying this by 1, wala tayong bina-violate na any rules of mathematics. So, the unit will be kilogram meter per meter squared second squared. And ito, pwede mo nang dalhin to sa baba. Okay? So, this will be meter squared, and then we can just remove this here. And itong part na to, this is Newton. So, we have Newton per square meter. Okay? And once you calculate that, we will end up with 27,440,532 pascals. And we can just convert this into megapascals. Okay? Since isang megapascal is 1 million pascals. So we can cancel this, put the pascals, so cancel din naman natin. Again, just move some decimal places. So we have 27.4405 megapascals. This is our answer. Oops. Yan. Okay. For the next problem naman, number 7 is, I think, naulit lang yung sa number 1 ng module. So let's move on to the next one. Okay. The pressure in an automobile tire depends on the temperature of the tire of the air in the tire. When the air temperature is 25 degrees Celsius, the pressure gauge reads 210 kilopascals. If the volume of the tire is 0.025 cubic meter, determine the pressure rise in the tire when the air temperature in the tire rises to 50 degrees Celsius. Also, determine the amount of air that must be bled off to restore pressure to its original value at this temperature. Assume the atmospheric pressure to be 100 kilopascals. So for this problem naman, No, so we have a tire. We have a tire. Not the best looking tire, but still. Yan. So, pagpalagay na ito yung tire. We may have to assume na even though yung tire is nilalagyan ng air and ang ating assumption is yung air, katulad ng sa balloon, is nafo-form niya yung shape of the container. But in this case, we can consider the tire to be a rigid body. So, when there's a rigid body, what we can assume from that is that the volume is constant. Okay, so this is an isometric process. Even though na yung tire is kapag mas maraming air, mas nag-iiba din yung kanyang shape and eventually it can explode if there's too much air inside. But for this problem, we can consider it to be a rigid body. So ayan, just so we're clear about the state points, since ayun nga, just like the cycles in thermodynamics, we have the Otto, diesel, Carnot, the Brighton, all that stuff. Meron silang kanya-kanyang state points. And yun lang, the same rin yun dito. But it's much more simpler. Okay? So, we have the initial temperature, T1, to be 25 degrees Celsius. And this volume is 0.025 cubic meter. So, ito yung volume na gagamitin natin all throughout the state, calculating the state points. Second temperature, 50 degrees Celsius. Now we have the atmospheric pressure of 100 kilopascals and the gauge pressure of 210 kilopascals. Oops. Ayan. And tinatanong sa atin, the amount of air that must be bled off. So you might be thinking it's the volume. No, the volume is constant. So it's the mass. The change in mass or the mass removed. Okay? So yung tinatanong sa atin, the mass of air to restore pressure to its original value at this temperature. No. So to restore the absolute pressure, I guess. Celsius. Yeah. And then we also asked to find the pressure rise, delta P. Okay? So dito, for the solution, let's do this as A. This is B. Okay? So part A, I think, let's change this. Since mauna natin masosolve to, actually. This is A, this is B. Ano? So, dito, let's solve. First, we have to determine the mass of the air inside the tire. And we can do that by applying the ideal gas formula. Okay? And isolating M, we will have PV over RT. And this is for the first state point. Okay? So we have, actually, we know that the absolute pressure is just the sum of these two. So this is 210 kilopascals. So we have 210 kilonewton per square meter times the volume, 0.025 cubic meter over R ng air, This is for SI, yeah, kilojoule. So that's kilonewton meter, kilogram Kelvin. And then yung T, the temperature needs to be absolute. So this is 25 degrees Celsius plus 273 Kelvin. Since it's not a change, we have to make it absolute. So yung hinahanap natin, the mass. So kilometer dito is kg. So cancel kilonewton. These will all get cancelled as well as the Kelvin. So we're left with mass, reciprocate, and you should have 0.0906 kg. Ito yung unang mass. You can store it at A. Now that we have the mass, we can calculate the change in pressure. Ano? Since dito naman, we're not altering anything yet. Ano? So the change in pressure, that would be mR delta T over V. Again, just modifying the ideal gas formula. This is M1. So, nakastore yun kay A. Then R ng air. Okay. And then the change in temperature, you can ignore yung units na. Ano? Since it's a change in temperature over the volume. And upon solving, cancel the rest of these. This will become 2. So we have kilonewton per square meter. That's Pascal. Therefore, ang ating change in pressure would be equal to 26.0067 kilopascals. So this is for A. Now for B, we have to solve yung mass ng air at a specific temperature na hindi nababago yung pressure. No. So dito, let's just try to make it shorter. So we have 210 kilopascals right there, multiplied sa 0.025. This is the PVMRT, by the way. It's equal to M. This is M2. Tapos 0.287 times 50 plus 273. Since ito yung dito natin. And we're maintaining the same pressure. Ano? Okay? And by shift solving, you can know that M2 would be 0.0836 approximately kg. We can store this to be. Now that we have M1 and M2, we can calculate the amount of air that must be bled off in order to restore the pressure to its original value when the temperature is increased. So the change in mass, delta M, is actually M1 minus M2. M1 natin na kay A, M2 natin na kay B, kg. Wait. This is the one I did earlier. Okay. Because I was trying to solve it as well. Okay. And your delta M would be approximately 7.0136 times 10 raised to the negative 3 kilograms. So, ito yung amount ng air na kailangang alisin. Ano, ito yung nasa condition. Okay? So, this was a pretty lengthy, not really that lengthy, but out of all the problems, this is one of the longest ones. Ano? Okay, so that's the answer there. Let's move on. Fine. Okay, for this is number 9. Okay. The air in an automobile tire with a volume of 0.53 cubic feet is at 90 degrees Fahrenheit and 20 psig. Determine the amount of air that must be added to raise the pressure to the recommended value of I think this was 20. I think this one was on the net. This one is 20. I think ito yung nasa module. Assume that atmospheric pressure is 14.6 psia and the temperature and volume of the air in the tire remain constant. So, yun pa lang, meron na tayong given na pagbabasayan natin. So, temperature and the volume is constant throughout this process. So, we have the volume to be 0.53 cubic feet. Tapos, temperature is 90 degrees Fahrenheit. And ating gauge pressure is 20 psi. Yeah. And then, atmospheric pressure natin is 14.6 psi. Together, we just add these. We have 34 points. Our absolute pressure would be 34.6 psia. Okay. Yeah, I think this is 30. Sorry. Ito yung nga pala yung ideal na part. Okay. Yung nasa ask natin, actually, ang ating nasa ask is, again, this is delta M, the change in air, but however, this is now added. To raise pressure to 30 psig, but this is the gauge pressure. So, yung ideal na pressure here, so there's another P-abs, which is the ideal one. So, ito yung given sa atin, and then, P gauge I. Okay? Ideal. That would be 30 psig. Therefore, ang ating absolute pressure, absolute ideal pressure would be 44.6 psia. Ito yung gagamitin natin. These two values here. Okay. Just clearing things out. Okay, let's solve. Ayan. So again, we're solving the first mass. So M1 is equal to PVRT. And we know that temperature and the volume is constant. So ang gagamitin lang natin is yung pressure. So ang ating pressure is 34.6 psi. That is pound force per square inch. Okay. And since yung kaakibat na unit for volume is feet, so we have to convert this into square feet. Okay. And we can do that by multiplying this by 144 square inches per 1 cubic square feet rather. This is multiplied by the volume, 0.53 cubic feet over R of air sa English. You should know this by now. That's 53.3 pound force per foot over pound mass Rankine. And if we want to have an absolute temperature, na-convert natin from Fahrenheit to Rankine, that you simply add 460. Okay, and now we can cancel some units. Ma-cancel to, and this, and this, and that. So, matitira na lang is pound mass, may reciprocate. And M1 would be 0.0901 pound mass. Start natin kay A. Now we find M2. For M2 naman, same process, palitan lang to ng 4. Okay? So let's try to do that here. Natin to. Transfer na lang natin dito. Like that. Okay? So, mass 2 still. This is P2 V RT. This is 44. And you'll end up with 0.1161 pound mass. Start natin kay B. So, yung delta M or your M added, this is your M added. Again, you have to analyze. It's the higher one subtracted by the lower. So, it's M2. That's M1. Okay. M2, naka-star kay B. M1, naka-star kay A. Your answer would be 0.026 pounds. So, ito yung kailangan nating i-add na amount ng air to raise the value of the pressure to 30 PSIG gauge. Okay? Moving on. Number 10. Yan. Ito medyo tricky. Even though the computation is short, medyo nakalito siya. But I'll try to explain the best I can. So, a soap film is formed on rectangular frame of length 0.05 meters, dipping in soap solution. The frame hangs from the arm of a balance. An extra mass of 3 times 10 to the negative 4 kilograms must be placed in the other pan to balance the pull of the film. Calculate the surface tension of the soap solution. And dito, we can try to illustrate, but medyo complex. Yeah. But we know that ilagay mo natin yung given actually. So the length is 0.05 meters. And then meron tayong mass. The mass is 3 times 10 to the negative 4 kilogram. Yeah. And ang tatanong sa atin, the surface tension denoted by gamma. And we know that gamma is equal to the force over the length. So in this case, it would be mg over the length. But we have to consider na yung soap solution, yeah, yung soap solution natin is a fluid that, let's say, ito yung soap solution natin. Ayan. Actually, like this. No. Gawin natin ng medyo rounded face. Ano? Kaya, let's say na nagfo-flow siya. Ayan. And then here. We have to account the phases of the soap solution. So, in this part, yung ating soap solution has two phases na nagfo-flow. And dito sa parts na to, let's say nandito siya, nagfo-flow. Nakaka-experience siya ng different forces at these points dito sa nagfo-flow. Since dito, we have an accommodating, let's say, air resistance, and meron din gravity. And then here naman, merong friction. So we have to account for that. So, dito, it has two free faces. So, it will be twice the length. Ano? If you look it up, parang ganun din yung magiging sagot niya. And we have to multiply now this by 1/2 para maging twice yung length. So, we will use mg over 2L as our formula. So, the mass, 3 times 10, negative 4 kg. Acceleration due to gravity, 81 meters per second squared. Over twice the length. Ano? So, it's 2 times 0.05 meter. Okay? And ang ating magiging answer dito would be 0.0294. This is Newton per meter. Yun yung unit natin dito. Okay? Alright. So that's the answer for this problem. Again, you can solve kung magiging ganun nga na kailangan pa maging twice the length yung ating soap solution. I'll leave it up to you guys. Yeah. So for number 11, calculate Reynolds number if a fluid having viscosity of 0.4 Newton second per square meter and relative density of 900 kilogram per cubic meter through a pipe of 20 millimeters with a velocity of 2.5. This, I think that's 2.5 meters per second. Set na lang natin. Okay. So let's say that we have a pipe. Ano? Okay. Parang cross-section lang ang pipe. Meron siyang velocity 2.5 meters per second. The density 900 kilogram per cubic meter. Ang kanyang viscosity, mu, 0.4 Pascal second. And ano pa? I guess that would be the D of the pipe. Ano? Parang length lang. I think that's the length. Or it might be the diameter. Nalagay lang natin dito. D pipe. It's 20. Since I think wala naman tayong gagawing much modification here. Except converting. So, ang as natin is the Reynolds number. Okay, let's solve. So, Reynolds number is equal to the density multiplied by the velocity times d over mu. And then, and just direct sub. Kilogram, meter, and then 2.5 meters per second. This is millimeter, so we'll convert this into meter over the dynamic, the viscosity of, let's break down the units. So Newton is kilogram meter second squared. Yeah. Cancel the kg. So it's going to be cancel. The seconds will cancel. This. And then the rest will just cancel itself out. So yun nga, Reynolds number doesn't have any units. And when you solve this, ang ating Reynolds number would be 112.5. Indicating na yung ating flow is laminar. Since it is less than 2,000. Okay? Yeah. Moving on. 2 more problems. Okay, for number 12, a ball of mass 10 kilograms is held under the surface of a pool. The instant it is released, it has an instantaneous acceleration of 4 meters per second squared toward the bottom of the pool. What is the volume of the ball? Now, I think we can apply buoyancy, Archimedes principle. So, let's denote our given. And let's illustrate na din. Okay? So, let's say merong ball held under the surface of a pool. Ano. Tapos nandito yung ground. The instant it was released, so ito yung time span na to is instantaneous, meaning parang walang nag-elapse na time, but it moved since it was instant. Ano, even though it might sound ridiculous na gumalaw siya na hindi nalampas yung oras, I guess that's how you would interpret it in physics. Second squared. Ano? So, I think parang yun lang yung information that we have so far. Yeah. And we're asked to find the volume of the ball. Now we can use the principle of buoyancy, where the buoyant force is equal to the density of the fluid multiplied by the acceleration due to gravity multiplied to the volume displaced. So ito ang hinahanap natin. Isolating, the volume displaced would be equal to the buoyant force over the density of the fluid times the acceleration due to gravity. And itong buoyant force na to is mg over the density of the fluid times g. So ito, you might think, cancel na lang natin. Not really, since we have an instantaneous acceleration. So dito, the actual buoyant force is m multiplied to the acceleration due to gravity minus the instantaneous acceleration over the density of the fluid times g. So we can cancel. Substituting the values, so since it is a pool, tubig yun, we have 10 kilograms, and then 9.81 minus 4 meters per second squared. Now, yun nga, like I said, tubig yun, so it's 1,000 kilogram per cubic meter. Like that. And then, makakancel lang tong units na to. And we'll end up with meter cubed. Okay? So, we will have 5.9225 times 10 raised to negative 3 cubic meter. Ito yung volume displaced. And yeah, the volume displaced is equal to the volume of the ball. Ito na yan. And if ayaw mo ng scientific notation, this is just approximately 0.006 cubic meter. Okay? Let's move on to the last problem. Number 13. Water flows through a tube with a diameter of 2 meters at a rate of 800 kilogram per second. What is the velocity of the water? Okay. So I think for this one, natin yung parang cross-section of the pipe. No, ganun. So the diameter, 2 meters. And yung kanyang mass flow rate. So let's say meron tubig dito. Mass flow rate is 800 kilogram per second. For us to find the velocity. Velocity ng tubig. Okay? So first, what we can do is calculate the area of the pipe. Wouldn't that be nice? Ano? Okay? So, the area of the pipe will be pi r squared or pi d squared over 4. So we have pi 2 meter squared over 4. And ito makancel lang. Actually. Well, yeah, makancel. Except for the unit, of course. So, ang ating area is pi meter squared. Yeah? Okay. And since water nga to, so we know the density of the water to be 1,000 kilogram per cubic meter. We can try to find the specific volume of the water. Yun nga, the formula for the specific volume is just 1 over the density. So, meron tayong 1 over 1,000 cubic meter per kilogram. Okay? And using this, we can calculate for the volume flow rate. Since we're given the mass flow rate and now we have the specific volume, we know that the volume flow rate is equal to the mass flow rate multiplied by the specific volume. So this is 800 kilograms per second multiplied by 1 over 1,000 per kilogram. So makancel to. And we're left with the volume flow rate. This is 0.8, by the way. Now, na meron tayong volume flow rate, we can calculate for the velocity. Since ang analysis natin is in units. So the velocity would be equal to the volume flow rate over the area. This is ang analysis natin dito. Like I said, this is cubic meter per second. And then we have pi meter squared. Okay? And then ito makakancel. This will be just 1 now. So it's meters per second. Na. Okay? And 0.8 divided by pi, just put it into your calculator and you will have your answer. 0.2546 meters per second. This is your velocity. I think I did that and do the other problems. So let's do it and do also. And so yung velocity ng water sa pipe na to is this, 0.2546 meters per second. And I guess that sums up the problems. Yeah, I think that's all for this problems for module 1, the practice problems. So if you have learned anything, well, that's nice. And I might have to prepare for school soon, so I'll see you guys later. Okay, thank you.